Hi guys, in the previous section we looked at cross-site request forgery and how it can affect a user and how we can prevent that. In this section, extra measures for the shop, we'll take a look at OWASP-ZAP. We'll see what two-factor authentication is, we'll talk about weak passwords and phishing, clickjacking, and finally wind up our course. In this particular video, OWASP-ZAP will talk about various features of OWASP-ZAP like plug and hack, fuzzing, and how we can scan for vulnerabilities using OWASP-ZAP. OWASP-ZAP is another vulnerability scanner, but it has some interesting features that I think we should look at. So first things first, you can find OWASP-ZAP by going to the web applications and web application scanners. You can find it there, or you can simply type it in command line, such as this. Now it does take a little bit to run, don't worry, if you've just clicked it in the menu, it does take a little while to set up because of the different things it's running. And as you can see, you can probably see it has Paros also running alongside with it to do certain capabilities. One of the things that I'm first going to look at here is the plug and hack option that we have available to us in Kali. And what you can do is to configure it, you can simply just click plug and hack, it'll go to it, click setup and say I understand and enable. I already have the add-on installed. As well as that, if that isn't working correctly, you can also in your preferences change the network connection to localhost to 8080 and it should be okay, and then it'll be able to read what you're doing on your browser. So right now we can see that nothing's here at all, and if we go to the alerts, which is fairly important if we want to know about vulnerabilities in this program, so the alert is there, and if we go down and just refresh the page and go back to iOS, we can see now it's loaded 4-5 alerts that it has here. So we have cross-domain JavaScript source inclusion, so I'm basically having a third-party JavaScript, so the Google API, I believe that is, yeah. Also we have other things like content type and X-frame options. If we just go ahead and use the spider option here down below, and we've already got it set as 192.168.1.3 because we're in that section. If we go over here, we'll obviously be scanning on the Google API site. We don't want that, we want to go on this host, so we highlight that, and then we'll click play, and it will start scanning in the current folders it already knows are available. So it will start to get other pieces as well. So the spider is done, and much like WEEF, we basically have a request and response that we can actually look at. So if we go back now and just enter login and put in sort of generic SQL error, we don't know what's happened here because of, like I said in previous videos, elements have gone in the way, but we do know that there's incorrect login details. If we go over to the OWASP-ZAP and go on here, we'll see the course login. We can see it actually has it available here for us. It hasn't picked it up yet that it's a MySQL injection, but it has noted that there is an error because sometimes some of these errors can be caused in different ways other than SQL injection, so that is why it's currently an application error disclosure. But it's really a good idea that I like from OWASP-ZAP that there's a thing called plug and hack where you can basically test out various things. It will log out everything that you have available to you, and you're able to check back and look at the alerts that it has available to you in this section. So what we can do is we can also fuzz. Fuzzing is basically where we're just trying everything that's possible to see if it comes back with an error. So what you need to do for fuzzing is basically highlight where we want to go for fuzzing and click fuzz in the requests. And then we're going to choose SQL injection for this, and I'm going to highlight SQL injection. I'm going to fuzz, and it'll basically try different possibilities that it has available to it within that fuzzing table that it has. But really what we want to see is the response that it comes back with. So we know that it is an SQL injection here. So if we look at a response, it's okay, it's 200 okay, but if we go down in the source code, we can see that it does have SQL injection there. And that's good if it's not working in one way and you're not sure how to do it another. You can just send a fuzzing and see what comes back, successful or failed. What I'm going to do now is I'm just going to simply just do an attack, which does take some time because it does various types of attacks on various inputs. So if we just click attack, what it will do is it will spider, it will do all of this for us automatically, and sometimes that isn't great and sometimes that is. That's why plug and hack and fuzzing is a good idea, and why sometimes automated attack sometimes works. So right now we have 8 alerts. If we just click attack and come back once that's done, we'll see what results have changed. So I've come back, it's about 15-20 minutes now since I started the scan. Obviously it'd be different depending on the size of the web application, and it's found a lot more than it would normally. It's found a lot more. It's got 13 now instead of 9. Found various exploits available to us, and we can use them. And also if we go into one, much like Weave, you can have a look in the payload it provides, and it also gives you a little bit of information. The description of a cross-site scripting attack is available there. In this video, we've understood how to set up plug and hack in OWASP. We configured it with a browser, changing the proxy so that it could listen properly. And this is great if we want to do a I call it semi-manual sort of scan of a web application, because you're basically getting alerts from the program from what you're interacting with, but you can also test it by yourself manually without having to use scripts that are pre-made for general applications. So you can do it in your own way but still get alerts, which I think is a fairly interesting concept. We also reviewed some of the OWASP features like plug and hack, like fuzzing, and also like spidering. There is a large amount of features in OWASP that can find vulnerabilities within a web application. In the next video, we'll be looking at two-factor authentication and how that can help users.
The Social Engineering Toolkit is an entire penetration testing platform that is intended to take advantage of the weakest link in any organization's security, and that is its people. I don't have the time to demonstrate all of the different capabilities of the Social Engineering Toolkit, but if you browse through the menu, most of them are pretty self-explanatory. For now, I'll demonstrate how to use the credential harvester in order to gather credentials by using a fake website. So we'll start by selecting 1 for social engineering attacks. And then on the second menu, we'll choose option 2 for website attack vectors. Then choose option 3 for credential harvester attack method. And then we'll use option 3 for custom import. And then we want to enter the IP address of our backend listener. So this is going to be the IP address of your Kali system. And this is where we enter the path of the HTML file that we want to use. And as it indicates here, it has to be an index.html file. So we'll go to Iceweasel. And here you can download any website that you want that has a login option and perform this exact same attack. But because everybody's familiar with it, we'll go ahead and use Facebook for now. So we'll browse to the target website. And then once at the login screen, we'll use File and then Save Page As. Then I'll go ahead and save it in my root directory, and I'll create a folder for it called Facebook. And then, as indicated previously, use the file name of index.html. And then you want to be sure that you save it as a complete web page and not just the HTML file. And then you can close out your web browser and then specify that path that you just saved it to. So we'll use root, Facebook, and then enter. And then we will use option 2 to copy the entire folder. And then here you want to enter the URL of the website that you're using. And now our harvester is now running on port 80 on our Kali system. So then what we want to do is perform a DNS poisoning attack against our target. So we'll switch over to our interpreter shell that we've acquired on the target system. Then what we want to do is alter the hosts file on that target system. This file will allow us to bypass DNS resolution. So change directory to Windows System 32 drivers etc. and then list the contents. And there we have our host file. So we'll use edit hosts. Then in the VIM editor, we can enter as many poisoned entries as we like. So we'll use the IP address of our Kali system that is currently hosting our credential harvester. And then we'll have facebook.com resolved to that IP address. Then we'll save those changes and use the cat command to verify that the changes were made. And here at the bottom, we can see that they were. So then we return back to our harvester and wait for the user to interact with that website. So then if we switch over to the victim system and open up Internet Explorer, and we're going to simulate the user browsing to facebook.com. So they entered the address, facebook.com, and as you can see, the site looks almost exactly identical to the actual Facebook site, so they suspect nothing. So then the user on the victim system enters their email address and password. So naivevictim@yahoo.com, and then their password. Then whenever they click login, it will automatically redirect them to the actual facebook.com website so that no foul play is suspected. However, if we return back to our Kali system, we can see that we have now acquired both their email and associated password. So that's just one example of how you can use the social engineering toolkit in order to perform a social engineering attack.
Welcome to AFSEC certification, penetration, test, better than the rest. This one dedicated to all those who complete the AFSEC certification, the ones who not falter and not waver. No ones who try harder and get braver. You must not fail, you must not nigga the bus. Try harder, you must. AFSEC, try harder. Only way to get your OCP. You must try harder, harder than you can believe. Cause that they AFSEC philosophy. AFSEC, try harder. Only way to get your OCP. You must try harder, harder than you can believe. Cause that they AFSEC philosophy. Burning against the desk, can't believe in such a mess. 6 foot deep inside the AFSEC penetration test. While you tunnel and you pivot, hit the dirt like a divot. Pain and suffering for me, say me know it's how you live it. But you must break yourself past your own perceived limits. When you want to show the tower and just say F it and just quit it. Same bar, but just don't get it. Show the answer one way easy than say forget it, kiddo. This is the AFSEC man, you must get with it. You want to be a giant or do you want to be a midget? You want to be AFSEC certified, the road they're developing widgets. Stick your head up off that desk and put the fingers on those digits. We got us playing around these parts. I'ma breathe it, I'ma live it, it goes. AFSEC, try harder. Only way to get your OCP. You must try harder, harder than you can believe. Cause that they AFSEC philosophy. AFSEC, try harder. Only way to get your OCP. You must try harder, harder than you can believe. Cause that they AFSEC philosophy. AFSEC certification, testing, penetration. Who's the man that tell him to say? Sit down on the desk, your fingers on the keys. Focus your brain, put your mind at ease. And check this out. She shot the vicious one, she laugh and at your face. You get humbled by the humble man, that's by your cyberspace. To roll down like marathon, that nickel 50-meter race. No wanna go crash or no burn, no wanna go far from no grave. 24-hour test, one for your head pump in low gears. But you can't fit it now, this a challenge, you must embrace. Till I'm straight, brush your teeth with some of that good old toothpaste. Do some push-up, drink some coffee, splash cold water for your face. Bring it back in at the game, so the world can know your name. That AFSEC certain like the acting Hall of Fame. There's no end to the acclaim, so your confidence regain. You come this far, the dust up now with us, they won't be crying shame. And I doubt you must have dropped this, the exam you cannot flop this. You also cannot stop this, so like Sue you must have shot this. Like Fro you must have mocked this, like Woodstock you must rock this. Buck up and let's try harder, me telling you, you got this. Harder and harder and harder and harder. Life's so very short, so give it all you got. Oh, the penetration test us a sample of things because you must so listen. Stay, try harder. Only way to get your OCP. You must try harder than you can believe. Cause that they have step philosophy. Stay, try harder.
SCAPI is a very powerful object-oriented scripting tool in Kali. In order to access SCAPI, enter the term SCAPI at the command line. The first object that we're going to look at is IP. So enter IP in capital letters, and then open and close parentheses. And then what we want to do is assign this object to a variable. So we'll do IP in lowercase, and then the IP object once again. And then use IP.display, and then open and close parentheses to see the different characteristics of that object. The object is already built with predefined configurations for each of the different characteristics listed here. We can change those configurations by using the variable.characteristic and set it equal to a new value. So IP.dst or destination, and then set it equal to an IP address of a Windows system that I have in my lab. Then I'll use IP.display once again to verify that the changes were made to that characteristic. And as you can see, this will update both the destination as defined and also the source address to our Kali IP address. Next, we want to create an ICMP object and assign it to the variable ping. So we'll use ping equals ICMP, open and close parentheses, and then ping.display to see the characteristics of that layer. And as you can see, by default, it's an echo request. So we'll then send the packet with Windows equals SR1, which is send and receive one packet, and then IP over ping. We'll then receive the reply, and we can review the results of that reply with windows.display. And as you can see, the result is an ICMP echo reply. And also, please take note of the TTL or time to live value of 128. Now let's try the exact same process, but this time we will send a ping packet and receive the response from a Linux machine that I have in my lab. So we'll use IP.dst and set the destination IP address to the IP address of our Linux machine. And then we'll do Linux equals, and then send and receive, and IP over ping. And then we'll do Linux.display to display the received packet, and once again an ICMP echo reply. But this time, notice that the TTL value is not 128, but instead 64. This is one of the common distinctions between most Linux and Windows operating systems, is that Windows starts the TTL value at 128 and Linux starts at 64. And for each hop required to get to the destination, the initial value is decremented by 1. This can be a very simple way of fingerprinting operating systems, or at least to distinguish between Windows and Linux hosts. So we'll exit out of SCAPI, and one of the great things about SCAPI is that it can be used or imported into Python for scripting purposes. I've actually already created a very basic Python script that tests to see if the operating system is Linux or Windows based. So we'll look at this script, and basically all it does is import the SCAPI module, and then takes input from the user regarding the IP address that you want to test, and then it creates the IP and the ICMP packet layers. And then if the TTL value is less than 65, it defines it as Linux. Otherwise, it defines it as Windows, and then prints the result. So we can run this real quick against each of our different systems. First, we'll go ahead and do a chmod 777 in order to change the Python script to an executable. And then period / and the Python script to execute it. And then we'll enter the IP address of our Windows host. And it immediately returns the result that the operating system is Windows. We can also try the exact same thing with our Linux IP address. So this is a very simple and crude example of how operating system fingerprinting can take place, and also an example of how you can use SCAPI within a scripting environment. So in the next video, we'll go ahead and look at some more advanced operating system fingerprinting tools in Kali.
Hello guys, today I'm going to show you how to use a slow script for DOS attack on Kali Linux. It's very simple. Basically you need just two commands to execute. Okay, I won't bother you anymore talking. Now open terminal and type this command to download the Perl script. Okay, we're just gonna wait a little bit to download the script, and then you just type another command. Okay, script has been downloaded. Next you need to do is type this command. I will attack this site because I already tracked the site and it's vulnerable to this Solaris attack. First let me check if the site is working at the moment. I'm on wireless, so my internet is kind of slow. Anyway, as you can see, the site is working. The site is working, and now we're going to execute a script. And we will check if the site is still working. And as you can see, the site is not working anymore. So we did it. Anyway, thanks for watching and see ya.